Alright, what's up everybody? Welcome back to part 2 of our Fahrenheit to Celsius converter. In the last video, we declared all our variables and assigned some values, and we did a calculation, and then we printed out our Fahrenheit and our Celsius, and we got our first line. We got our 0 and -17. But obviously we still have to do all of these, right? So there's a few different ways. So there's a really terrible way of how to do that, and I'm going to do that first, and then I'm going to explain the way better way, right? So we might be tempted to do it like this, right? Because right now our far is equal to 0. And we know that our next thing that we want to print out, we want to print out the case where far is equal to 20. So what we can do is we can say far equals far plus step, right? And what this is doing is it's taking the value of far, which is currently 0, and it's taking the value of step, which is currently 20, and it's adding those two things together, and then it's putting them into far. So now far is equal to 20, right? So it's a little weird looking, right? Because we've got far over on this side and far on this side, or we're assigning far to itself. But remember, we're not really doing that, because what this does is it evaluates everything on the right side of the equal sign first. So this far just becomes 0. It evaluates to 0, and this plus step evaluates to 20. So it's the same as if we had said 0 plus 20, right? And if we assign 0 plus 20 to far, we know that's just going to be 20. So here we have now made far 20. And we can just do this same thing that we already did again. And in fact, if I hit escape and I hit YY on this line, then I can copy it, and then I can hit P on this line to just paste it, and then I can go up here and copy this one also and paste that one, right? So what this is going to do, I'll even go ahead and run this to demonstrate that it does indeed work, right? We can convert or compile that and run it, and now we have two lines, and they are the same as the ones that we would expect. Obviously, there's going to be a problem here, though, and you may have guessed. What it is. The problem is going to be that we still have a bunch more lines to write, and if we have to sort of copy and paste this all the way down, that sort of defeats the whole purpose of programming, right? Like, programming is supposed to make our lives easier. We could just use the calculator, right? If we had to write all this, we might as well just use the calculator. So we're going to take advantage of the fact that these two lines are the same. In fact, this line is the same also, because if we wanted to do it again, right, if we wanted to make this 40, we could do far equals far plus step again, right? Because now far is 20 and step is still 20, so 20 plus 20 is 40. So now we've done it again. So we could use these three lines over and over again to make these. Well, it turns out that we don't have to keep writing them out over and over again, because we have this thing. I'm just going to delete all this nonsense. We have this thing called a while loop. And what a while loop does is it allows us to execute the same any kind of loop. I'm going to use a while loop in this example, but there are a few different types of loops. But a loop, as you might imagine, allows us to loop through the same few lines of code over and over again for as long as we want. So, well, I'm going to leave that comment with the Celsius there because it makes sense. But I'm going to write a while, and I'm going to throw this bracket down here. Tab these out, because this is what I was talking about with proper tabbing. Generally speaking, whenever you're inside of some curly brackets like this, it's good practice to tab in everything in between this and this. So you see that the main is all the way to the far left, right? And then I've got this curly bracket here, and then this curly bracket, which is the end of my main. And everything that's in main is tabbed in one space, except for this while, because this while opens a new bracket and closes its bracket here. So everything that's in this while loop is tabbed over again, so it's double tabbed. So that makes it easier to read for someone who's going through. They're like, oh, what all is contained in this while? Well, everything that's tabbed in right here is contained in this while. Again, C will not enforce white space. Like, you could do it like this, but don't. But so one thing we notice about this while is that it has a similar sort of syntax to, and you can put a space there, but I don't like to. It has a similar syntax to a function, right? Like, it's got a parentheses thing here, and it's not technically a function, but it is kind of similar. It's called a control statement, I think, is the formal definition of it. But essentially what we're going to do is we're going to put some sort of evaluator in these parentheses, right? We're going to check something and see if it's true. And if it's true, we're going to do all these lines of code until we get here. And then we're going to go back up here and we're going to check our thing again. And that might make a little more sense if I put the actual expression in here that we're going to evaluate. So what I think we should check, and I happen to know the answer, so it's not like I'm being super smart or anything, but we're going to check this: far less than or equal to upper. And this symbol is the same as, you may have seen like the less than or equal to sign, which looks sort of like, let me see if I can grab one real quick. Sure. So, I mean, you probably didn't need me to grab that, right? Like, I think we all kind of know what those are, but obviously that's not a symbol that we can type on the keyboard. So instead of typing that, we just type the less than symbol and then the equal symbol. And C knows that we mean less than or equal to. And we can also write it like this, and that is greater than or equal to. But we don't want to do that for this particular problem. For this particular problem, we are going to evaluate whether the variable Fahrenheit is less than or equal to the variable upper, which, as you may remember, was 300. So what's going to happen here is essentially this. We're going to have, I'm going to use this over here to sort of keep track of what our variables are, right? So right now our variable far is 0. Let's just say that we've started this program from the beginning, right? Our variable far is 0, and our variable upper is 300. And we get to our while loop, and it says, hey, is 0 less than or equal to upper? Is 0 less than or equal to 300? And obviously 0 is less than 300. So it says, okay, good, do this loop once. So it does everything in between these brackets, which is, it does this calculation, assigns the value to Celsius, prints out Fahrenheit and Celsius, which in this case is going to be 0 and negative 17, and then it does this far equals far plus step, right? So that changes our value of far to 20. And then we hit the end of our while loop, so we go back up to the top and we do this evaluation again. And we say far less than or equal to upper. Is 20 less than or equal to 300? It still is, so we're going to do everything in this loop again. And that's how we're going to print out, this time, 20 and negative 6, because this time when we do this, far is 20. And we can keep doing this, until we get all the way up to 280, right? And then we'll do Celsius equals 5 times 280 minus 32, all divided by 9, which is going to give us 137. And then we do far equals far plus step, which makes it 300. And then we go up here, and 300 is not less than 300, but 300 is equal to 300. So we're going to do it one last time because we hit that equals the time that it was equals. So that's this last line here. And then what happens after we print it out is we do our far equals far plus step, and that gives us far equals 320. And then when we come up here, it says 320 less than or equal to 300? No, sir. 320 is not less than or equal to 300. So this statement here is no longer true. So we're going to not do this. In fact, we're going to go all the way down here, and we're going to just continue on with the program from the end of the while loop, which in this case is also the end of the program, right? The end of main, because there's nothing else after that while loop. So our program exits. But it doesn't exit until after it's printed out all these things, which is what we wanted it to do. So that's pretty useful, right? It saves us a lot of writing, because we could have wrote each one of these out each time like 16 times, but we didn't want to do that. So we use this while loop instead. The only problem that we have to worry about with a while loop is that we could do it that it never ends, right? Like let's say that instead of far here, I accidentally put lower, right? Because if you remember, my lower value is 0. Well, I don't want to put that equal, but you know what I mean. This lower value is 0. But we never change the lower value inside this while loop. So after we do our first iteration, right, far goes from 0 to 20, and then we come up here and we check is lower less than or equal to upper. Well, 0 is less than or equal to 300, so we're going to do the loop again. And then we update far to 40, but we haven't changed lower. So we keep doing it, and we will never end, and that's what's called an infinite loop, right? So you have to be careful when you're writing loops. You want to make sure that there is you code in some way to make sure that your while loop will eventually end, right? Because this will never end. In fact, let's run it just for sort of amusement purposes. Whoops. If we run this, see, it just keeps going and going, and it's getting so huge. And if you ever find yourself in an infinite loop like that, you can hit Control C, Control C to force quit your program, because it will never end, right? Like look how many, and obviously the computer runs super fast, because look how we're already at like, what is this, 2,638,200 degrees. So we went up quite a bit here in a pretty quick amount of time. But that program, it went all the way. Anyway, that program will never end, and that's bad. We don't want that. But like I said, if that ever happens to you, my stupid thing, there is a way to put this in like a script file so that every time you open your VI, it just does the changes that you told it to make, so that it's always the way you want it. And I just haven't done it because I was busy doing this, but maybe I'll cover that real quick in the next video, because it is annoying to have to change it. But anyway, you don't want to have infinite loops, but you can hit Control C to get out of them if you find yourself in them. But for now, we're going to go ahead and put far back in there. And one last thing that I'm going to do here is I'm going to change this to a slightly shorter syntax. You can actually use something called plus equals step. And this is the same as but it's just obviously shorter, right? Because it turns out that adding stuff to a variable is something that we want to do fairly often, and it can be kind of a pain to write, my variable equals my variable plus the thing, right? So C provides us, and most other C type languages, probably all other C type languages if I had to guess, although I don't know that for a fact, but they provide you with this sort of shortened syntax where if you put a plus equal sign, then it's the equivalent as saying far equals far plus step. So we can do this, and we don't have to write far twice. So that's just sort of a nice little thing. Oh, and then the other thing I wanted to do was, instead of putting a space here, I'm going to put a tab escape character, space tab, because obviously, as we saw, when it gets bigger, when the numbers get bigger, their spacing is not going to be exactly right. Like these are all tabbed right, right? But if I used space instead of tab, then this one would be there, but then like this 48 would be out here, so they wouldn't all be in order. But if I use the tab, then they're all sort of in line. So I'm going to use this %d to get the far, percent, escape t to tab, and then %d to get Celsius, and then and then escape n to go to the next line. And that should be all we need to, there we go. I wasn't in there. That's all we need to do the code that we want to do. And as we can see, we've got this, which looks identical to this, except that that's where it went. Okay. So, so you can see that we have this, which is identical in values to these over here. And that is the end of that particular coding example. In the next video, I'm going to go over how to use some floats to make our code a little more precise. So that should be exciting as well.